Welcome to tool number 2, or part 2, renaming and simplifying. So here we go. I'm going to do, the first example's already done for you. It's the easier example. I'm going to do B and C and D for you. So here we go. Let's look at part B. Again, we look at the tougher side. The left side's actually really easy. Nice cos squared x, so I'm not going to worry about that. But I do have on this side sine x squared plus 2 cos x squared minus 1. So I'm going to talk about the right side here. And what I'm going to actually do here is I'm going to break this guy right here into cos squared x plus cos squared x. Why am I going to do that? Because I can see that identity right now, sine squared x plus cos squared x equals 1 is going to work well here. So I'm going to have here sine squared x plus cos squared x plus cos squared x minus 1. And again, what beautiful thing do I have here? Again, this guy right here is all equal to 1. My grade 11 identity, so I really have 1 plus cos squared x minus 1. Guess what? 1 minus 1 is 0, so I really have cos squared x. So because left side equals right side, therefore, quaeresta demonstratum. Done. Alright, let's go to the next one. Here is the next one. Alright, so I got sine x over tan x equals cos x. What I would do here is I'd actually write this as a division statement. So I'm going to tackle the left side again. Not again, but I'm going to tackle this side. So I'm really going to have this. And when I have fractions like this, I actually like to write it as division statement. So sine x divided by tan x. Now, Mr. Wills, what is tan x? Of course, tan x is sine x over cos x. There we go. Beautiful. So what is that really? Well, I'm going to change that division statement to a multiplication and flip that fraction. Reciprocate that fraction in mathematical terms. So sine x times cos x over sine x. Beautiful. And what beautiful thing happens here? Ooh, that's gone. So what do I really have here? I have equals cos x. Well, because left side equals right side. Whoops. Therefore, quaeresta demonstratum. Done. Alright, here's the next one. Cos x squared minus sine x squared is equal to 2 cos x squared minus 1. What would I want to attack here? Well, I'm looking here and I see that everything is in terms of cos except for this guy. So I'm going to get rid of this guy. Mr. Wells, how can you get rid of this guy? Well, I know that sine squared x, is equal to 1 minus cos squared x. How do you know that? Again, the sine squared x plus cos squared x is 1. I just rearrange it. So I'm going to change this guy to that. Why? Because I see everything on this side in terms of cos, and this has a sine in it. I want to get rid of that sine, so I can do that by using that identity. By the way, this will not work for this. It will not work for sine x is equal to 1 minus cos x. Sine squared x is equal to 1 minus cos squared x. So here we go. I have cos squared x minus, and here 1 minus cos squared x. So equals, and here we go. Well, I really have cos squared x minus 1 plus cos squared x. Again, there is that hidden negative 1 here, right? So it's really negative 1. I multiply both terms by negative 1. So what do I have here? I really have this 2 cos squared x minus 1. So, done. Because left side equals right side. Therefore, quaeresta demonstratum, that which was shown has been demonstrated. That's the end of part 2.